Okay, hello everyone. Let's give it a few more seconds for everybody to get settled in, and then we will start this session. Give it just about a half a minute. And hello everyone, and welcome to another great webinar session organized in collaboration with Velo 3D, a company that in just a few years has radically changed the way manufacturers across multiple market segments make and get their metal AM parts. We have a lot to talk about today, so let's get started. First, I'd like to introduce myself. My name is Davide Scher. I am a journalist and market analyst. I am the co-founder and CEO of 3D BPM, a leading media and market research company that specializes exclusively on the additive manufacturing or AM industry. 3D BPM publishes 3D Printing Media Network, one of the leading news and editorial online portals trusted by AM professionals all over the world. We also conduct extensive market research and publish reports on all the core segments and key verticals of additive manufacturing, from energy to aerospace and related markets. Today, we're here to learn and explore how Velo 3D's unique metal AM technology helps contract manufacturers, hereby referred to as CMs, address and reach their expansion objectives. Typically, the specific capabilities within a CM tend to be customized for their existing customer base. This means that expansion within industry or towards other industries is difficult. We will look at this fundamentally important subject with support from Schiller Blackman Oilfield Technology GmbH, or SBOT, a leader in manufacturing for the oil and gas industry. We will see how SBOT is taking this challenge head on, with support from Velo 3D's end-to-end manufacturing solution and Velo 3D's technical sales engineers. Today's discussion, we look at Velo 3D's unique sales model and how Velo 3D is a unique 3D printer OEM. To accelerate their clients' growth, Velo 3D builds a portion of the demand for their CM for free. They consult with OEMs during the design phase and educate them on what is possible with the most advanced metal AM technology on the market today. This process is attractive to OEMs as it unlocks new levels of performance and supply chain agility. But it also creates demand from the differentiated manufacturing infrastructure that Velo 3D provides. SBOT has the vision to both expand inside of its flagship traditional energy markets, but also to grow into new markets such as space, aviation, and emerging energy technologies. By leveraging Velo 3D's proven metal AM capabilities and their application sales-led model, SBOT expects to do what very few CM companies have ever done: take their business to new heights. So let's meet our speakers. Matthias Judd, head of engineering at SBOT, who was initially scheduled to join us, could not be here today, so he's going to be perfectly replaced by Tom Dorfmeister, global head of sales at SBOT, who has extensive experience in both CNC machining and AM. He gained experience on production machines, and for several years, he was the managing director at SBOT subsidiary in Vietnam. Daniel Wutzelhofer is business development manager. Hi, Daniel.
Hi.
At SBOT. Here, his wide experience in several business areas supports the company's diversification. He has knowledge in CNC machining industry, working with companies in the oil and gas, aerospace, renewable energy, and automotive sectors. Daniel's enthusiasm and practice for innovation offers SBOT customers broad experience in new manufacturing options. From Velo 3D, we have Sales Director for UK and Nordic, John Porter. Hi, John. Who oversees Velo 3D's ongoing expansion efforts in the key markets of the UK and Nordics. After earning his degree in engineering product design from South Bank University, John began his career in AM with James Dyson in the 1990s. His background includes leadership positions at various AM companies. Before joining Velo 3D, he was at Renishaw in a role that combined key account management and working directly with SAE, ASTM, and BSI in the development of new AM standards. And we have Javier Fruit. Hi, Javier. Sales Director France at Velo3D, where his AM expertise supports the company's expansion in Europe. He has proven success working with different AM technologies such as DED powder, DED wire, and PBF for machines and parts. Javier is dedicated to his customer success in their transition from conventional manufacturing to additive manufacturing and helping them enter the next era of engineering. Hello, everybody, and thank you for being here. Before we start, I would like to make a few service announcements for the audience. First of all, the webinar is going to be recorded, and you will automatically receive a link to download it. On the right-hand side, you will see the materials that the speakers have made available for you to download, presentations and other content. We want this to be as much as possible an informative and interactive session. So you are all welcome to ask questions that will be answered during the panel session or at the end of the discussion. Please write your questions in the chat window on the right-hand side of the screen. And let me just make this an announcement in writing. Okay, so without further ado, let's jump right into it. Daniel, let's start with you. Building on this long premise that I made, can you help us understand what differentiates SBOT's business and activities today in the oil and gas segment?
Yeah, so thank you, Davide, for the introduction. Schoeller-Bleckmann Oilfield Technology is the global market leader in the production of high-precision components made of non-magnetic, high-alloy stainless steel. Our group is equally recognized worldwide for our high-efficiency drilling tools and equipment for the oil and gas industry. I will show you at first the presentation of our company. So Tom and I will present you some slides of our company, and at the end we will show you a short video that you get some views of our facility. Schoeller-Bleckmann Oilfield Technology is a 100% subsidiary of Schoeller-Bleckmann Oilfield Equipment AG, with the headquarters in Ternitz in Austria. On our facility in Austria, we have more than 350 employees, and on a production area of 45,000 square meters, we have more than 120 CNC machines in operation. With our experience since 1924, we gained expert in several business areas and special production processes. Our company is certified according to ISO 9001, ISO 14001. We are also a qualified aerospace supplier according to the EN 9100. And we are also certified according to the API. SBOT's core business is the oil and gas market, where we are the global market leader in the production of high-precision components. With our knowledge of several process technologies, which Tom explains later on, we decided several years ago to do also diversification on other business areas. These business areas are the mechanical engineering, the aerospace, the space, and the renewable energy. In these business areas, we offer our wide range of experience as a one-stop shop. That means our service starts from the raw material provision over prototyping up to the serial production. Like parts, big shafts for generators in the wind power or hydropower, or also if you go to the aerospace market with structure parts for airplanes. Our wide range of experience, which are our core competencies, will be now explained in more detail by Tom.
So yeah, we'll start with one of the most important process for us to produce our own steel, which is our cold forging press. It's a 1,500 ton pneumatic forging hammer, which achieves a 10 to 15 degree compression on the material. Straightening machine and peeling machine. We offer full automatic measuring of the straightening process in-house. And with the peeling machine, we remove the surface. The material, we develop our own special non-magnetic steel for the oil and gas industry. Each bar is tested in-house, like fatigue tests, tensile tests, impact and hardness tests are done, and every bar is certified by us in-house. Shot peening, which is a special surface treatment process, is also provided, which is available in stainless steel and ceramics. Stab welding process, which is a special welding process with a welding level of 1 degree narrow gap welding. Laser cladding. We have several mill turn CNC machine centers with our high modern machine park of more than 120 CNC machines. We can produce highly complex outer and inner contours up to 10-meter lengths. Turning a milling process can also be done separately. BTA deep hole drilling. We can handle inner diameters up to 250 millimeters on a length of up to 13 meters. Honing, gun drilling, which is special technology in-house for drilling holes starting from 3 millimeters. For this process, we have the possibility to control the deviation of the drill. The diameter range is from 3 millimeter to 25 millimeter in diameter and up to a length up to 4,500 millimeter. Gooseneck drilling is a special eroding process technology for borehole deviation. So S-shaped boreholes are possible. Additive manufacturing. With the new Velo technology, we brought our additive manufacturing to new heights. And quality control. Every single part is 100% quality checked, which is done in-house with programmable CMM machines. As you can see, we offer a wide range of know-how, which we've gained over the years, which we can offer in several business areas.
With a short movie, we want to give you a view to our production facility here in Ternitz with our worldwide more than 400 CNC machines with the special processes what we have here. You can see, for example, the cold forging, the CNC drilling up to the 10 meters, the gun drilling, the CNC turning with the ink canal special material which we also have, and the laser welding, and last but not least, and also the new Velo technology machines what are installed within our group and also in our facility. And last but not least, the quality control, which is done here in-house.
Fantastic. Thank you very much for that presentation. And I really have a quick question for you. Also, I'd like to remind the audience that we want this to be interactive, so feel free to write questions as soon as you have them in the chat window. And one question I have is, given the current situation of the oil and gas prices, being very high, do you think this will affect in any way your adoption of AM in one sense or the other, like more or less AM?
Yes, it will definitely affect our business. The market in the oil and gas industry is very volatile at the moment. It's good to be in the oil and gas industry with the oil prices being so high, but the previous year showed that it can be also very difficult. Therefore, we have decided to diversify our market and our portfolio, and also enter new business areas, and with special focus on 3D printing, because we see real opportunities. And now with Velo on board, with this technology, we can definitely support customers in their design freedom.
Of course, that makes a lot of sense. So Daniel, let me ask you, which industrial segments are you now looking to expand into?
Yeah, as I also explained earlier, the segments or the markets where we want to expand is on the one side, the mechanical engineering, like also pump manufacturers, valve manufacturers, and so on. Then the aerospace market, the space, and also the renewable energy, like also the hydropower and the wind power.
Great, fantastic. And so what are the reasons that are driving you to do this in this particular context, or in general?
Yeah, in those business areas, we can expand on the one side with an additive manufacturing process, and on the other side also with the machining process. So that means we can offer our customers a wide range of production possibilities. So not only the printing, also the post-processing of the parts. Then with the new space, it opens new possibilities also with the Velo technology. The aerospace market will definitely come back, and with the mechanical engineering, there is a big potential on the market with several machine manufacturers.
Perfect. And I would like to also, the audience probably saw it, but we are running a poll to understand the status of the various industries that our audience is coming from. We will leave it open for a little while, and then we will look at the replies to use this as an input for further conversation. So, Tom, what are the main challenges that you are facing when expanding, when trying to expand into a segment that is not your core business?
Well, it's good question. Thank you. It's one of the biggest challenges that companies accept, get trust, and understand this new technology. It's very necessary to enter in early stage of the design of a project to help the designers to get the most out of the technology. It's pretty hard to develop a customer with an existing supplier base if you ever offer the same portfolio. You have only a chance with a new technology they don't use at this moment of time. And it's a long way to get interesting inquiries of potential customers. At first, you have to convince them of the technology and that you are the right partner for new projects.
And so let me follow up to that with another question. How is your partnership with Velo 3D helping you to address these specific challenges?
Well, the cooperation with Velo has grown very strong, very quickly. They are helping us in regarding of the component production. Velo 3D offers a great network with the technical sales engineers and sales directors on the market. They're very open and collaborative in their business culture. The potential of new customers, since they need manufacturers of Velo 3D. And with the Velo 3D technology, it's possible to overcome limits in the metal 3D printing.
Great. And let's learn a little bit more about how that works. So let's drill a little bit deeper into Velo 3D's state-of-the-art metal AM technology and the company's, as we saw, unique business approach. John, to you, can you give us an introduction of the company and technology?
Of course, yeah. Thanks, David. Velo 3D, 2014 is when it started. So the company was originally created by Benny Buller. And he came into the additive manufacturing space when metal additive manufacturing had a lot of promise. It was considered very exciting, very innovative, and very enabling. And it was always a situation where you were trying to develop new products and new parts and give the opportunity for those to be manufactured in a new and a modern and a very exciting way. But essentially, it isn't always possible to print what you want. And Benny was very frustrated by this. It was a core discipline that we had as a business, that we wanted to provide the market with the ability to print exactly what their design is, with no compromise. So I wondered, I was hoping to have my slide deck. Here we go.
There we go. I was gonna say, yes, we have a slide.
Thank you.
We have a set of slides.
So the company is starting to grow fantastically well. Our European market is deeply important to us. And in the last year alone, we've grown the team here in Europe over a number of new positions and new roles that's already been explained. So we have technical sales, we have sales directors, and we have the ability to support all of our customers and all of our new contract manufacturers as they come on board. The company as well recently was listed on the New York Stock Exchange, which was hugely exciting for us, and it's given us the ability to accelerate our growth, not just here in Europe, but across the whole of the world. We have what we refer to as an end-to-end solution. So we don't just sell the additive manufacturing machine. What we need to make sure people understand is that we need to bookend that machine itself with two critical pieces of software. So we have our build preparation software, and we have our post-build assure quality management software as well, to allow you to understand exactly how the process is performing. And essentially the machine in the middle is just a tool to provide the manufacture of the hardware that you've designed. So let me talk a little bit more in detail about the machines themselves. The family of machines that we have is called the Sapphire Family. We first launched the Sapphire machine that you see there on the image, and this is the machine that the guys have got at SBOT. They're running Inconel on their machine, and this is our first machine into the market, and it works on a standard build platform for us, which was defined as 315 millimeters in diameter and 400 millimeters in the Z. And so what we've done is we've essentially distilled that as well into integrating a taller version of that. And as you can see there, there's a representation of the build chamber there. It builds on the same diameter, but at 1 meter in the Z dimension as well. So both the standard Sapphire and the Sapphire MZ run two 1 kilowatt lasers. And those 1 kilowatt lasers interact across the entire workspace. They typically build in 50 micron layers. And all of the family have our unique non-contact recoating system, and the software and everything that we work with works directly from your CAD model. So a nice added asset to the way that we design and develop our systems to work, because we take your feature-rich CAD model and we work directly with that. We don't interact with the STL format in any way at all. I think that's a huge benefit to a lot of our key customers. The machine as well is fantastic in its ability to self-calibrate. So we have the ability to produce each build from a known datum, starting from the exact 000 position. And what we've done is we've taken this core machine architecture and we've grown it again. So the final machine that we now have is the Sapphire XC. That machine, we shipped our first one at the end of last year, which we're hugely excited about, and we have a fantastic order book for future business. That machine is much larger. It again utilizes the 1 kilowatt lasers that we have in our standard machine, and that 1 kilowatt machine architecture is carried across. But we have 8 lasers in the XT machine, and it builds on a 600 millimeter diameter build plate. And the opportunity there is also to go to 550 millimeters in the Z direction. And what I mean about the usefulness of the family of architecture in that we can essentially allow our customers to develop products in our standard Sapphire and our Sapphire 1MZ. And then when they have the ability, or where they have the requirement to grow the volume of their business, to grow the volume of the parts they require, they can move that acquired knowledge. Those approved parts can be moved directly onto our XT platform with no compromise. It transfers directly across. So that is a fantastic asset. And essentially what we do with our build preparation software is we provide the opportunity to build what we refer to as a golden build file. And that allows you to run that golden build file on any Velo 3D machine in globally, essentially. If it's running the same material, you can build the same part anywhere in the world. And that, again, is a unique asset of what we do. So if we look a little bit more detail about the kind of parts that we make, high value. I mean, it's typical of what we do. So anything or any component that has something flowing through it or needs to manage the exchange of heat is a core component for the process that we've defined. We do kind of sit in a unique space. We look around the world of additive manufacturing, and we often talk to our customers about building parts that they've always wanted to build, maybe in AM or maybe in other processes, but parts that have always left them frustrated because they just haven't had the opportunity, or there just isn't the capability within their existing processes to manufacture. So we look at those types of parts as being unique to us because we have unique attributes within our process to allow us to build parts that others can't build. And that is a fantastic asset. Our customers, these are fairly typical of the industry, but these are growing all the time for us. And we've got a very strong foothold in the space and the aerospace industry. Our success in the US has been phenomenal over the last few years. And that's growing now into other sectors like oil and gas, and hence the relationship that we've got with SBOT. But there are more diverse markets that we're moving into now, and we're very happy with the way that the marketplace is starting to engage with this technology. They're starting to understand the unique benefits of the Velo system, and they're starting to engage with us. And the SBOT guys were talking a little bit about how much support we provide. It is critical. We do provide a lot of support free of charge to customers or clients that are coming into our technology. It's important that people truly understand the assets that we have, the unique design capability. People often talk about the frustrations of design for AM. We don't really believe those rules apply to us. We actually prefer to kind of flip it around, and I like to often refer to it as AM for design. We want to sort of give back the design freedom that is often promised. And as I mentioned, we often talk about how exciting this technology is and how innovative it is. But essentially, we want to deliver on those original promises. It's super important for us. And if we look at the materials, I've already mentioned that the guys at SBOT there, they've got the machine installed now in Austria, running Inco 718. But the material families are shown just there. We've got a lot of core activity in the nickel superalloys, of course, and titanium is a key runner for us as well. But you'll also see that we've got some new materials coming through, very exciting. And we develop as a business, we develop all of the material parameters in-house. We provide the material parameters as a recipe, and we give that set of parameters with the machine. And those parameters are kind of held in the machine and allow you just to sort of plug and play, allow you to print your build file against parameters that we've done all the research and all the development work on to create. So they're fundamental to the success of what we do. And it's really important to reiterate that when we allow our customers to work on our machines, we allow them also to diversify their supply chain. We allow them to grow their business using our contract manufacturing network. We're equally engaged with our contract manufacturers as we are with our end users. And Xavier will explain a little bit about our relationship on the contract manufacturing side in a moment. But it's quite important, I think, really, for people to realize that the machines that we supply are production ready. We are very much involved in the volume manufacturing of additive manufactured parts. We're very keen to provide our investors or the people who invest in our equipment with high uptimes and very considerable OEE, to know that they've got a good return on their investment, and it just makes parts. To the point where I started my little piece here by saying, the promises of additive have always been that it's so exciting and innovative and enabling. But really, the secret of additive, if going forward, is it really is just another manufacturing process, and it should be viewed as that. And essentially, what we're really trying to make it, and this is mentioned in a presentation I went to recently, if only this process was just dull, consistent, and predictable, I think we'd all get along with it much better, because we need to start recognizing it, that it's a true workhorse of manufacturing, and it can be relied on, and it can produce parts of quality and parts that can be qualified for a wide range of applications.
Thank you for that. Thank you very much. You were going to add something to this, Javier?
Oh yeah, I can explain a little bit more about our contract manufacturer networks and how it works, because it's very important, and I will say it sticks to it defines also Velo3D identity on the market. To explain this, I will do it in three, I will say, different through three different questions. Is why do we have contract manufacturer first? This is important, and why do we talk about? Our main focus is to put, as John said, a lot of effort to deliver a quality process and quality products in order to allow our machine customers to push the limit of 3D printing. It's not to develop in parallel our own 3D printed part business. I mean, we have no time for this, and certainly not to compete with our own customer. So the 3D part production, especially the Velo 3D parts, is the mission of the contract manufacturer, as SBOT is. We will maybe keep on our side, some special development asked by customer, for example, very high sensitive parts or new material. But for all customer looking for buying parts, we will use and redirect them to our network of contract manufacturer. So what is a contract manufacturer? What defines this? So a contract manufacturer, so we call them in Velo3D the CMs. It's typically a company as SBOT. SBOT is really a good example, and I would say experienced that personally when I was in Austria. Having a lot of, so that means their main mission is producing and manufacturing conventional parts, and through different ways. That means machining, forging, casting, post-process, in respect of specific quality standard due to typical markets, and also customer specifications. They know how to manage a part manufacturing. That means in a supply chain, and also I would say its life in a value chain. And we, Velo3D, we will include our solution in their production capacity. And this approach is also very interesting for OEM, because we create for them a kind of copy of their existing supply chain. And sometimes our CMs are already integrated in the OEM supply chain. And more generally, it's also very interesting for all types of customer, because it's not at the end just a question of printing parts, but really a challenge of delivering finished product. That is our contract manufacturer's expertise, not ours. And what is interesting, because we have contract manufacturer, we have a Velo3D production capacity around the world, but how we make them successful, because metal IM is, I would say, not an easy market to address. But they have first, as all our customer machines, they have an extensive onboarding and training process, so they can understand deeply how to run our technology, and are able to print the part at the best process performances, and also up to the highest Velo3D quality standards. And secondly, they have business support from us, so from the sales team and the technical sales engineer, as we will redirect to them all our part opportunities, so they can grow their customer base, and also be introduced in new markets they are trying to enter in. So before they can increase themselves the workload on the machine, we can generate demand on their own machines. So that helps a lot to start their business in additive. And finally, they also have, during all machine life, full access of full and free access of our teams. So they get full support from application engineer, so who will help them to make
the part printed correctly, so well prepared, well programmed, and have, I would say, a maximum chance of success as the first print. And also they have all the support to their dedicated field engineer, which will make sure that the machine is, how can I say, healthy and is available. So to sum up, between contract manufacturer and us, it's not only that mean a customer-supplier relationship, but they are really becoming partner and member, I will say, of the Velo 3D family and community. As we said, we have a strong relation with our contract manufacturer, frequent updates about the business, about opportunities, and also about support they will need from us. So that's really key for our own development and also their own success in Metal IM.
Thank you so much for that, Javier. Now, before we move on, we have a lot of questions coming in from the audience. And also, I wanted to give you an idea of the results of the first poll. So the first poll was, what is the trend in the markets that you are present in today? And 50% of the audience replied aggressive growth. So that's great, actually. 38% said historic growth, but 31% said stagnant, and 15% said declining. So that's over 45%, of markets that people need to, grow beyond in some cases. I also wanted to let the audience know that we've started the next poll, and we will look at the results of that. I don't know if any of you want to comment the results. If not, we can move on to some of the questions from the audience that are actually very, very interesting in some cases and connect to what we are talking about. Okay, well, if you want to comment, just go ahead. I have one of the first questions connect back to something that both John and Javier said about designing for additive. I know this is an issue that I actually had a chance to speak with Mr. Buller about. What are the scopes of design for additive manufacturing in today's today and in the evolving, for additive and in this evolving technology within the Industry 4.0 landscape, and how relevant would it be? How relevant is design for additive in the manufacturing process, in the additive manufacturing process? I don't know if John, you said you were talking about this before.
Yeah. Well, really, right now, design for AM is entirely relevant, but that's somewhat unfortunate. We often speak to designers, and I think this industry always speaks to the designers, and they will use the latest CAD software and the latest optimization software to create a design where you can simulate the performance and you can understand that you've truly extracted the most you can possibly get from the part you're designing in terms of its performance, whether it's thermal or fluid dynamics, for example. But design for AM, even within the bounds of Industry 4.0, it will always provide some sort of constraining factor. It'll be effectively a series of compromises that you have to step back from your optimal design to allow you to build, even with the promise of being able to use additive manufacturing and how enabling that potentially could be. You're still forced to abide by the rule book of design for AM, and that typically means that you need to put in place anchors or supports to allow the part to be built distortion free. And the opportunity that I mentioned is essentially by taking additive manufacturing and allowing people to design freely with it, and that's Velo 3D's opportunity. That's what we have as our USP. We've developed our process to step away from the rules of design for AM. We allow customers to build parts support free. Some unusual geometries are now achievable using our technology because we have characterized the way that we build parts in a slightly different way. We've built the machine to a different architecture. Benny came from the semiconductor industry, and what he's done is he's used the experience he had there to define a framework for our machine that is much more related to the semiconductor industry, in that it has a lot more process control in place, and allows us to work much more closely with the process, understand its positives and minuses and its good points and bad points, and really accentuate the good, and allow customers to build support-free where possible. It's not to say we don't use supports. If supports are easy to apply, easy to remove, and they guarantee build success, we will still use them. That's fair to say. So it's not a case that everything we build is devoid of any support. But design for AM is something that we want to bury as a company. We want to make it extinct. This is the approach that we've taken, and we've taken very successfully. So it's allowed us to move into what I said is a sort of a parallel space where there's metal AM and then there's Velo 3D AM. It allows us to perform in a very different way.
Thanks.
Just to complete, what is also interesting, and when you are talking with a customer and you go to the conclusion and see the benefit of, I would say, having more design freedom and I would say have less compromise on the design, they understand then all the benefits of the Velo 3D technology. And this is quite interesting, because sometimes can be a long process, because optimization and design for additive manufacturing is quite an established rule now, and it's sometimes it's challenging and to point where they can move forward with I would say using less this kind of rule and pushing then the limits and the performance of the parts they have to deliver.
I think that's great, and actually also answered the second part of this question, which was how necessary is it to redesign every part, in order to make it ideally printable. With Velo 3D, a lot less parts need to be redesigned to be printable.
We've actually had a lot of success doing direct part replacement. So again, another area where additive manufacturing often fails. Metal AM is an opportunity to us. So we've had some success doing direct part replacement. So something that's been designed for conventional manufacturing, milling, turning, drilling, milling, we can make it too.
And actually, the story of Velo 3D started with this. It was not competing with I would say part already printed in metal or manufacture conventional, but try to take the one the customer cannot manufacture, where sometimes it's where they have I would say a lot more value at the end, because it's their daily pain, it's their daily I would say frustration about challenge they have to succeed in.
Fantastic. And I'm sorry, I'm going through a lot of questions, but I have a very quick one. Also on technology, is what kind of laser do you use in the machines?
It's a fiber laser, so it's American manufacturing, made in America. I think it's a terbium fiber laser. So I think one of the points to stress here is, although we have some fundamental differences in what we can do, some of the raw ingredients of our machine, some of the componentry are very typical of this industry. So we have fiber lasers, we have gravimetric control, we have a laser powder, we have powders with the same particle size distribution that everybody else is using. So there's a lot of commonality, but it's just we use those similar ingredients in a different combination.
Yeah.
And there was another question on design for additive manufacturing, but let me move on to an application question. So I don't know if SBOT can give us some insights into, do you think you can use CNC machining and additive in relation to solar panel production? Because you mentioned, are there applications that you're already looking at into that kind of new energy source production segments?
Yeah, so the additive manufacturing, we offer, as I also mentioned before in my presentation, we offer to the customer a wide range of production possibilities. On the one side, we offer the additive manufacturing, and then we can also do the post-processing for the parts itself. So the customer will get at the end the complete product.
And can I just answer that as well? That's a really interesting question, and it actually lends to a lot of information that we already have as a business, because prior to starting Velo3D, Benny was directly involved in the solar energy sector. So if we have a direct question there and somebody there would like some more information, then please do get in touch, because I think if you were looking to combine the requirements of the solar power energy sector with additive manufacturing, with post-processing, with machining, with all the work that the guys at SBOT can do, then I would suggest we're extremely well qualified to help.
Fantastic. And this is another very specific question, which can be answered by both in terms of applications and in terms of technology. But what are the challenges in the area of advanced material characterization of the end user parts by combining finite element simulations and their experimental validation? I don't know if we want to go this deep into it, but in general, what are the challenges of material characterization? I know you've been working on you did a lot of work on standards, so you probably also looked into this topic, John.
I don't have an awful lot of experience in this area, I'll be very honest. And I know that a lot of characterization can be done through simulation, but at the same time, I think that we're still in a place where you need to have, well, really, there's no substitute for building certain amounts of test parts and test coupons within the development of a process and a product you're trying to qualify. I don't think we're able to step away from that right now, and we can use a number of software tools to allow us to move that understanding and that awareness and that knowledge to a new level, I guess. But if I look around our business and I look around the businesses that I used to work with, then I think it's fair to say that there's still a very heavy reliance on good old-fashioned material qualification processes and technologies, and I think that'll remain for a little while. I think the industries that we serve, the aerospace and the space industries, have a very high expectation of knowledge, awareness, and as a business, we're making our own steps to qualify and validate materials. And what I mean by that is we've taken the unique position by entering into a piece of work with SAE, so one of the standard writing organizations. So we're producing what we believe is the first set of MMPDS data for additive manufacturing. So as a company, we have the confidence to essentially create a design rulebook for additive manufacturing. The first instance is in INCO 718. It's a material we've talked about already quite a bit. But essentially what it'll provide is documented evidence of all the design allowables that you would need as a design engineer to build qualified parts using this technology. So it's a measure of the confidence that we've got in our ability to produce highly repeatable production parts, because we can now, we're just about to publish it later on this year, and it'll essentially allow you to define a vertical 3mm wall, for example, and understand the attributes of that feature in terms of its tensile, its fatigue, its elongation to break. So that MMPDS data, those design allowables, is something that we're committed to in material characterization, and we will provide those soon as a unique asset to our customers.
Thank you. And okay, we don't have that much time, so we'll do one more question, then we'll move on to conclude the presentation, and then we'll take other questions. One thing that came in is about a startup looking to use metal, Velo3D's metal AM technology. I know we're here to discuss, really large companies such as SBOT and their use of this technology, but I know Velo3D, especially in the US, also works with several startups. What would be the process? Is there, or how would they go about it?
The best way is simply to make contact. You're right. We've got a great history in working with startups, We're a company ourselves. We're born of Silicon Valley, so we were a startup once. We kind of get it. The industries that we supply and serve very much across the world now are often in that kind of startup phase. They don't want to go through the heavy investment of capital, tooling, and etc. So they want to access our technology, metal additive manufacturing, successfully. And I have huge confidence here that they can approach the guys at SBOT. They can approach us directly through our sales network or through our technical sales network. They can engage with us as well. We've just committed now to having our own facility here in Europe as well. So if that question has come from somebody here in Europe, then the news is great. We've built a technical team, and we have a new facility here in Europe, which are planning to open in the next few months. So if I can just get onto my slides. Can I just move? I can't. So I don't think I'm going to move it on to the next slide. Thank you. Here we go. So this is a nice connection to receiving any inquiry from a startup. We've made a commitment to have our own facility here, our own technical center here in Europe, and it'll be based in Augsburg. So it's just north of Munich. So we've taken up some space and a workshop and offices in this facility here, which is a fantastic looking building. Internally, it's connected to a lot of our potential customers. So we have an internal network which we're already starting to exploit, which is fantastic. But it should be a representation of the kind of access that we can now provide to our technologies for any startup. They can come and see us. There'll be a machine that will be running there, and the technical team that will be based there as well will be able to integrate and work directly with any startup to design relevant parts for a Velo 3D system.
So what is important also to say, we really, I will say, ask people to, I will say, submitting us, I mean, parts, examples they want to look at. That means we will enjoy to analyze them and put figures, that mean consistent figures in front of these cases before, I will say, printing any part, or I will say have to get any budget. We do, I would say, support-free part, but we do support-free support to our customer, but also free support to our future customers. That means all this pre-sale process is free and helps people to better understand the technology and also have less risk to analyze and get all these figures to make that decision.
Fantastic. I also have a question from about giving some examples of where the Velo 3D strategy has been successfully implemented in the past. I know we've covered some of these, but maybe you wanted to give some more details on that, John.
I'm sure. One of the key bits of success is through our contract manufacturing network, because what it allows us to do is it allows us to work with our prime customers, and it allows us to suggest to them that they can use our contract manufacturing network to expand and grow their business. And what I mean by that is, and this is some success we've had certainly recently and continuing in America right now. We've got a large space customer who have a huge demand on their own Velo machines. They have a huge number of them. But as their business grows, they need more and more parts. And as they have adopted and they've invested in Velo 3D, what it allows them to do is to take their build file that's been prepared by us and the build file that they would use internally every single day. They can now ship that build file to any one of our contract manufacturers, and that would include the guys at SBOT, to build their parts. So the confidence is there that it allows people to grow their business into our contract manufacturing network, and it also allows us, our contract manufacturing network, to grow our prime business as well, because we see the two are very, very interconnected. Early engagement through contract manufacturing is perfect for most people, and it allows them to reach a point where they have enough critical mass to consider their own investment. Yeah. But it also allows them to have a more distributed manufacturing process as well. So they could, for example, build parts at SBOT in Austria, but then as their business grows, for example, it may be in oil and gas, and they then need to start producing parts more locally in America, then they can send, as I mentioned before, that exact build file that the guys at SBOT have created. They could send it over to another Velo machine in America and build exactly the same part, and essentially create one of the other opportunities within Industry 4.0, which is distributed manufacturing.
Great. And so, what are the next steps? For your European expansion plan.
So that's a good transition. So as John said, so our technical center is I would say finished. We are finishing the installation of the technical center. You will be able to see soon Sapphire machine, and also come and visit us for some trainings and also see nice parts. But as a good transition, if you want to know more about us, you can just meet us in the upcoming events when we will be where we will be. So first in April, so John is participating to the Mac exhibition in Birmingham in UK.
Yep.
We will also be, and I will be at Turbine Forum in Nice. While in May, our colleagues from Italy, so Roberto Esposito, the sales director, and Riccardo Tosi, the technical sales manager, will be at MEC4 in Parma, and also at the Industrial Valve Summit. To go deeper into the technology, we will also organize 2 roadshows. So one on April in Nice, and another one on May in Italy, in Bergamo. So what is a roadshow? So it consists in a seminar where we will focus on educating engineers, the technology influencer into a company, and also the decision maker, to better understand the benefit and capabilities of the Velo 3D technology. And how, I would say, as we said, how we can transform their business thanks to the end-to-end advanced manufacturing solution we have developed. We will discuss the capabilities of the process. You will have also demos, live demos, and also be able also to see parts, and also to talk deeply with us on your own case studies. It's so if you want to meet us, you can book a meeting even from the trade shows or the roadshow. So you can access it on our website. So it's located in the subsection resources, roadshow, and trade shows. And you can book a meeting, or you can simply also to be updated about where we will be attending and participating to events. You can just follow us on LinkedIn.
Thank you very much. We have a couple more questions from the audience. This one is to all participants, again from different points of view, about NDT technology. So non-destructive testing, which is so important in additive in particular. So in producing for critical markets such as aerospace and power generation and defense, using AM, how important is NDT in your strategy for Velo 3D or in your applications for SBOT? Is there any specific NDT technology that you're already using? And if so, what are the defects found in the parts or in the technology? What can be improved? I'm sorry. Maybe I can ask. I know you mentioned something about inspection. The guys at SBOT. I don't know if you wanted to expand a little bit on non-destructive testing activities at SBOT.
So, well, for non-destructive testing, we are using so far, it really depends on what is required, how critical is a part, and what is defined from a customer on their specification, what kind of non-destructive testing do they require on their parts. So we do have a whole range of non-destructive testing available here already for our current machining parts, like ultrasonic testing, dye penetration tests. But whatever is required outside of our portfolio is very often specified from the customer. And if we don't have it in-house, we will use outside contractors to get these verified and tested. Of course, if the demand is growing, we will definitely bring in this technology in-house. But yeah, for a start, we are using outside contractors to do NDT testing or special NDT testing, which we currently do not have.
Perfect. Okay, thank you. I don't know if you have you given any thought about how relevant NDT is to the parts that you produce with your technology at Velo3D.
It's super important.
Your customers produce actually.
Yeah, it's super important. It's important to get value out of every part you make. So if you can test it and understand it and analyze what you've built without destructing it or destroying it, then of course then there's huge financial and commercial benefit there. I think if I was to add to that, if the analysis that we're able to provide through our Assure software, so our build validation software, you could argue that has a degree of supporting information that would sit around any NDT activity you choose to make. We're able to look at each build on a layer by layer basis. We're able to look at any kind of typical alarms that come through any one of our onboard sensors. And we've got nearly 1,000 sensors on board. So we can start to look within the control limits whether there are issues that we should interrogate and look at, and we can do that through our own software. We can do that through our reporting software, and we can look into the build, and we can actually see photographically or through a structured light scan or through any of the onboard metrology as to whether there may be a region of concern, and maybe a small area of porosity or something like that. It happens. It's the reality of our process. So it happens from time to time, of course. But I think if we can consider now aligning typical NDT processes like CT scanning and aligning that with our Assure software and putting the two together, I think it's a very, very powerful resource to understand how good the part is that you've just made.
Of course. Thank you.
Clearly, the Assure software can help us to prevent and to detect this kind of porosities, lack of fusion, or powder bed instability. And with the monitoring, this monitoring tool we have in process, we can, I would say, maximize the level of quality at the end of the part. But the NDT will still help you to find porosity, problems with density, cracks, etc. Yeah.
Absolutely. Okay, so we really have we're really out of time. We have a very quick last question about also for SBOT about have you ever used, are there applications that you can imagine that where you use CNC combined with additive? After the printing or before, or I don't know, before maybe not, but after the printing, is there applications where you need to use CNC after on a printed part? Right? Have you already had that kind of applications at SBOT?
Yes, so we also have some parts where we have to do some machining afterwards the printing. So, for example, if there is some
thread cutting, for example, required, or some sealing surfaces which need to be polished, of course, you need to do some kind of post machining as well.
Exactly.
Yeah.
Okay, makes sense. Well, that's really all the time we have for today. It has been really a very informative and interesting session. I encourage everyone to reach out to the Velo3D team or visit their website at www.velo3d.com. Big thank you to our great panelists, and thank you everyone for joining us today. See you all next time. Bye-bye.
Thank you.
Thanks.
Thank you.
Thank
Bye.
you.
Bye.
Bye bye.